All right, guys. Before I start getting an onslaught of questions, I had a couple people contact me through Google Classroom about, are there any problems on the quiz where an inverse doesn't exist? So we would have addressed this in class. I certainly alluded to it in the videos, but just to make sure, okay, we take something as simple as f of x equal x squared. Okay, something as simple as that. Okay, it's the simplest quadratic you could come up with that leads to the simplest, okay, of parabolas. Now, clearly, if you look at this, it fails the horizontal line test. So what that means is there's not an inverse function that serves as an inverse for every point in the relation, okay? That doesn't mean the inverse function doesn't exist. It just doesn't work for every single point in the relation, okay? And I'll show you what's going on here. So if we go through the same process, the same exact process where get it out of function notation, I'm sorry, I'm writing 2x rather than just x squared. Okay, we switch the x's and y's, and then we solve for y by taking the square root of both sides. What happens is you get y equals radical x. Okay, now we know that obviously this is y equals x squared. And if I take a look at y equals the square root of x, okay, I know what that looks like. Okay, that guy's going to look like this, okay, right here. Okay, and so we say, okay, well, why doesn't this work out everywhere? It has to do with the domains and ranges, okay? So we say right here, what's the domain here? Well, the domain would be the set of all real numbers. Okay, so the set of all real numbers, okay, or we could say from negative infinity to positive infinity like that. And I say, well, what's the range then? Okay, and you say, okay, well, the range goes from 0 to positive infinity, and it includes 0, okay, like that. So if an inverse, okay, if an inverse existed everywhere, okay, then what would have to happen is, okay, this range would become this domain, okay, 0 to infinity, okay, and this domain would become this range, okay, the set of all real numbers. But that doesn't happen, okay? Now, is your domain 0 to infinity? Okay, that would be yes, that works out. The problem is the range the set of all whole numbers? Okay, that is a big no. Okay, so we say, okay, well, what's going on here? What is the range, okay, of y equals x squared? Well, it would start at 0 and go to positive infinity, like this. Okay, so we say, okay, well, how do we make that happen? You would have to go back and say, okay, I'm not going to use this. I'm going to say, okay, this is 0 to infinity, which means that if I go to the graph and I say my domain is just 0 to infinity, it gets rid of all of this over here. Okay, so what happens is we have an inverse that exists for only half of this guy. So the inverse exists for the right half of the guy, but there is no inverse for the left half of the guy, okay? So what happens? Sometimes certain educational eggheads say that the inverse doesn't exist at all. Well, clearly it does. The inverse exists for this half of the function, but there is no inverse for this half of the function. Okay, so what that allows us to do is actually go and find the inverse function. Okay, so no matter what you start with, there's always going to be a function that serves as its inverse. It's just, it won't necessarily act as an inverse for every single point in that relation. Sometimes it will and sometimes it won't. But you can always find this guy. Always. Okay, find him. Okay, you can always do that. Okay, so hopefully that helps you out a little bit. Okay, so on the quiz, okay, I think it's quiz 12, where it says find the inverse function. Okay, this is what you're doing. You're finding that guy. Okay, and don't worry about whether or not it passes, okay, the horizontal line test. Okay, we talked about this a little bit in class. I talked about it extensively on the videos, but if you notice the last couple of videos I do, I don't even address this stuff. Okay, the reason being is that we want to find that inverse function. Okay, it might serve as an inverse for everything in the original function or just some of them. So hopefully that helps you out.